Hey there, Geometry. Mr. Lamb here coming to you with the 4.1 and 4.2 practice quiz that you worked on today in class. This looks very much like your quiz for tomorrow. Tomorrow's quiz will have every single type that you see on here will be covered on that quiz. Quiz is a little bit shorter. I think I trimmed it up just a little bit on the number of questions, but I did put on 2 bonus questions. And your hint, if you're listening to this and watching this video, your hint for the bonus is I hope that you have watched all of the videos in Canvas for 4.1 and 4.2, especially the one where you are writing your own Pythagorean triples. So if you have not seen those, I would highly recommend going back and watching those. It'll really help you with the bonus tomorrow. Okay, so question 1 and 2 ask us to find x and show all of the steps. Leave answers in simplest radical form and or fraction form. Questions 1 and 2, you really have to be careful. I have a lot of people that keep looking at these saying, oh, this number 1 looks like it's 30, 60, 90. And you're right, it does look like it, but it does not tell us that it's 30, 60, 90. So you are not allowed to make that assumption. If you know 2 sides of any right triangle, even if it is 30, 60, 90, even if it is 45, 45, 90, or if it's any other combination of right triangle, if you know 2 of the sides, you will always use the Pythagorean theorem. So in question number 1, I plan on using a squared plus b squared is equal to c squared. Now I have to determine a, b, and c. And most of you already know this, that c is always the hypotenuse. So this is my c. And then a and b are just whatever my other 2 legs happen to be. So if I'm going to do Pythagorean theorem, I'm going to do 25 squared plus 75 squared. And that will be equal to x squared. Well, 25 squared is 625. I get that by doing 25 times 25. And 75 times 75 is 5,625. So that is equal to x squared. Then I add the 2 things together and I get 6,250 is equal to x squared. All right. So that means x is going to be the square root of 6,250. Square root of 6,000, I have to simplify that. And I'm going to need a lot more room for that. So I'm going to actually click over to a new page. All right, 6,250. I'm trying to find this square root. So I'm going to do a factor tree. This is 625 times 10. And this is 25 times 5, and 10 is 2 times 5. I do have some primes here. 5 is prime, 2 is prime, 5 is prime. 25 is not, so I'm going to break that down into a 5 and a 5, both of which are prime. So I now have the square root of 6,250. Is actually the same thing as saying 1, 2, 3. Oh, I'm sorry. 625 is not 25 times 5. It's 125 times 5. Look at this. What in the world? All right, here we go. And now I have 25 times 5. And now I have 5 times 5. That looks better. And list all my primes here. So when I start listing out all of my prime numbers, 1, 2, 3, 4, 5 fives. 2, 3, 4, 5, and a 2. So if they're going to get out of the square root, they come out in groups of 2. So there's a group of 2. So a 5 comes out. There's a group of 2. Well, 5 comes out. And no more groups of 2. So what made it outside of the radical? I see 2 different 5s, so 5 times 5 is 25. And inside the radical, I have 5 times 2, which is 10. So I can finally say, back here, that the square root of 625, or 6250, is 25 radical 10. 25 radical 10. Number 2, same thing. I don't know anything about my angle, so again, it's a squared plus b squared equals c squared. So my legs are a and b, and my hypotenuse is c. So I will have x squared plus 16 squared equals 32 squared. So that's x squared plus 256 equals 32 squared, which is 1024. I'll subtract 256 on both sides. And 1024 minus 256 is 768. So x is going to equal the square root of 768. Again, I have to do the same kind of process here. So 768, the square root of 768. 768. 4 will go into that, I believe. So 4 goes into 7. Whoops. 4 goes into 36. 9. 192. So 4 is going to be 2 times 2. 192 is going to be 2 times, so 19, 9, 96. 96 is going to be 3 times 32. 32 is 8 times 4. 8 is 4 times 2, and this 4 is 2 times 2. And this 4 is 2 times 2. Woo! So a little bit faster. So let's see, prime numbers. 2, 2, 2, 3, 2, 2, 2, 2, 2. All right, so 768. Going to be the square root. 1, 2, 3, 4, 5, 6, 7, 8 2's. And a 3. All right, what can come out? Well, here's a group of 2. 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 So coming out is going to be a 2 here, a 2, another. So 4 2's came out. So 2 times 2 times 2 times 2 is 16. And inside the radical, I'm just left with that little 3. So the square root of 768 is 16 radical 3. All right, jumping down here to questions 3, 4, 5, and 6. These are special right triangles, so I do need to know where to put my m's. I've been using the letter M quite a bit in class. So it says find x and y. So I'm going to go ahead and I'm going to put all of my m's and everything in right now. We'll do it in an orange color. So number 3 is a 45, 45, 90, which means that the legs are both m, and the hypotenuse is m radical 2. Number 4 is a 30, 60, 90, which means the short leg is m, the long leg is m radical 3, and the hypotenuse is 2m. Number 5 is another 45, 45, 90, so it's going to be the same thing. Legs are m. Hypotenuse is m radical 2. And another 30, 60, 90, short side is m. Hypotenuse is 2m. and m radical 3 for the long way. All right. Now that I have those in there, that's my first step. I'm going to find an equation. So for number 3, here's my little equation right here. I have m is equal to 10. So m is equal to 10. And then I try to solve it for m. The good news is it is solved. M does equal 10. So I am done. So that means y, which is down here on the bottom. I see that y is equal to m. So y is equal to 10. And x is equal to m radical 2. And that is 10 radical 2. And that does not simplify anymore, so that is done right there, 10 radical 2. For number 4, find my equation. Here's my equation right up here. So m radical 3 is equal to 4 radical 3. Divide both sides by radical 3 to solve for m. So m is equal to, well, radical 3's cancel on both sides. So m is equal to 4. So that means x, over here I see that x is equal to m, so that is 4. And y is equal to 2 times m, and 2 times 4 is 8. So x is 4 and y is 8. Right, number 5, find my equation again. So right here, m radical 2 is equal to 10. So m radical 2 is equal to 10. Divide both sides by radical 2. Cancel. So m is 10 divided by radical 2. And I'm not allowed to have a radical in the denominator. So I'm going to multiply by something that is the same as 1. So I will choose radical 2 over radical 2. That fraction is equal to 1. So the top, 10 times radical 2 is 10 radical 2. The bottom, radical 2 times radical 2 is radical 4. And the square root of 4, hopefully you know to be 2. So radical 2 times radical 2 is just 2. Look at your fraction out in front. You have 10 over top of 2, and 10 over 2 is 5. So this is 5 radical 2. That's what m is equal. So y is equal to m. So it is 5 radical 2. X is equal to m. So it is also 5 radical 2. Both of them 5 radical 2. Number 6. Look for my equation. Right here is my equation. 2m is equal to 24 radical 3. Divide both sides by 2. So m is 24 divided by 2 is 12 radical 3. So y is equal to m. So this is 12 radical 3. And x is equal to m times radical 3. Well, if I think about this, let me show you over here kind of what's going on in my head right now. I have 12 radical 3 and then another radical 3. So 12 radical 3 radical 3. All right, so 12 radical 3 radical 3. Well, radical 3 times radical 3, I know that. That is 3. And 12 times 3 is 36. So x is equal to 36. It's equal to 36. All right, number 7. Just about done. Finishing up. Question number 7 says list 2 common Pythagorean triples. Now there are a bunch of them. I gave you 3 of them. List 2 of the 3 that I gave you in class. Now the easiest one to remember is probably 3, 4, 5. And then either of the next 2. You can either do, I like 5, 12, 13. The other one would be 7, 24, 25. Would be the other one. Either one of those two are pretty good. And then this last question. This last question says, is 21, 47, and 23 triangle a right triangle? And then, is it a Pythagorean triple? So remember, if we are going to prove that it is a right triangle, the first thing I need to check is it a triangle? And if it is, then the two small sides, A plus B, have to be bigger than the third side, which we call C. So in this case, my question is 21 plus 23, the two smaller, is that bigger than the third side of 47? Well, 21 plus 23 is 44. And is 44 bigger than 47? And the answer is no. So not only is this thing not a Pythagorean triple or a right triangle, it's not even the sides of any triangle. So this is not a triangle at all. So no, it's not a right triangle. No, it's not a Pythagorean triple. Now, just for the sake of argument, let's pretend that this did work. All right, let's say that I did 21 plus 23, which is 44, and let's say that my other side was 43. So 44 is bigger than 43. The second step to this would have been checking to see if a squared plus b squared equals c squared. If it does, if this is true, if a squared plus b squared equals c squared, this will prove whether a triangle is a right triangle. That's how you can prove that a triangle, so if it passes test 1, it'll pass test 2 being a right triangle if a squared plus b squared equals c squared. And then lastly, it is a triple. We call that a Pythagorean triple if we have whole numbers. So if I don't have any decimals at all, that will make that a Pythagorean triple. So this one was a no, but possibly on the quiz it could be a yes. So make sure that you first check and make sure that it is a triangle. Secondly, make sure it is a right triangle. And then lastly, check to see if those whole numbers make it a triple or not. Hopefully you guys got something out of this video. Be sure to go back and watch your other videos in Canvas. And best of luck tomorrow on your quiz.